This one's going to look a little bit different because we're going to be flipping back and forth to Decimos to kind of give you an idea of what would be an additional way to solve these kinds of equations, which are not so burdensome, because some of these are just terrible to do pen and paper, and there's no reason that you should do that ever, aside from ridiculous testing scenarios. Normally we would use a graphing application or some kind of technology to help us whip through these in a matter to deal with efficiency. So we're going to look at these pen and paper real quick, and then we're going to look at some technological applications that allow us to answer these kinds of questions. Not just D, but A through D are all of our learning targets for this section. So focusing specifically on absolute value equations and inequalities, if absolute value of x is equal to A, then x is either, the input of this number right here is either positive A or negative A. It's one or the other. We don't know which one it is, so we just have to solve for both. So my input was either A or negative A. It was one of those two. So when I set these equations up, kind of like the assessment we had last unit where it was a tricky one like this value right here is either equal to positive 13 or negative 13, and then solve this. 2x, 14, x with either 7, shift that over, negative 6. So our two options are that x was either 7 or x was negative 6. Doesn't matter which one I plug in, both of them provide an output of 13. Okay, so this is a nice friendly one. However, of course, in the real world, it doesn't always work like that, and they want to look at some horrible possibilities. So let's look at this one right here. Yuck. 4 different things could happen. It could be exactly what it looks like, just with the positives. It could be the absolute opposite of what it looks like, right? It could be where this is what it looks like, but this is the opposite of what it looks like. These are all negative signs I'm putting in there. That's not just a little tick mark. Same thing here and here. Or this one could be the opposite, and this one could be exactly what it looks like. Oh my gosh, what a disaster. I don't want to solve 4 equations. What a terrible, terrible time that would be. Well, if I understand the concept of equality, and I know that -1 times A equals -1 times B, whatever the case may be, I know that if I divide that -1 out, since I'm dealing with equality, then this inner term right here and this inner term right here, the thing that the -1 is multiplying by, must be the same. So that means that these two equations here and here are the same equation. I don't need to solve it twice. And then funny enough, I have the same kind of concept going on here. A equals -B, so -A equals positive B. It's the same thing, it's just written a little differently. Okay, they're both equivalent expressions, which means that I don't need to solve both of these, I only need to solve one of them. So let's solve this friendly one, and then it doesn't really matter which one we choose here. We'll just, I don't know, that one for whatever purpose. So solve 5x equals 6 and x equals 6/5. That's option A. Oh, that's an 8. Silly. 8/5. And then option B, which is from this side, when I distribute through that negative, right, so this was quantity times -1, this becomes -2x and +1 equals 7 minus 3x. Nothing changed there. So let's shift this guy back over. Now I just have 1x, and when I subtract that, it's 6. So these are my two options, this one and this one. If I wanted to, I could check it on Decimos. We're not going to do that on this particular problem. We'll look at them later on Decimos. Inequalities. These are the ones that are terrible because there's a whole lot of different ideas that we have to wrap our brain around when we're doing inequalities. So let's look at kind of a simple one. If the absolute value of x is less than some number, so let's look at an example and then go back and write the rule instead of giving you the rule to apply. Let's say I'm saying that x is less than 5. So x must be, the number I put in had to be smaller than 5, right? But if I put in a number like -6, the output would be +6. +6 isn't smaller than 5, it's bigger than 5. That means there's kind of like an end cap here. So we're looking at values that lie between these two numbers. So these are always and statements because we're looking for something that lies between 5 and its opposite. So if x is less than a, the absolute value is less than a, then x must lie between a and its opposite. So that's the rule for that one. However, if the absolute value of x is bigger than a, we'll come back here and look at 5 again. If absolute value of x is bigger than 5, then some of the possible inputs could have been 6, 7, 8, so on and so forth. So anything this way would work. But also, if I come down here, if I were to plug in -6 into this, it would spit out +6, true statement. So I also have to include this portion of the number line as part of my answer set too. So in this case, x is either bigger than 5 or, these ones are ands, these ones are ors, or x is smaller than, we're going to use a, sorry, a, smaller than -a, the opposite of a. We're using our 5 here to help us think about that question. I want you to give yourself a second here to write a rule or make another example problem for yourself. Okay. Let's look at one here and we'll see how we're doing on time. I might have to skip to a video to look at Decimos. Here's one. It can either be written as this, or because this one is one of the ones where my input was a value that created an output that was bigger than 8, so it must be this way or this way. So I'm going to write it like that. Solve it out. X is greater than or equal to, I don't know, 5, I think is what it works out to be. And then 3x is equal to -1, -1/3. Okay. Something to think about or remember, which isn't a big idea, which you may have forgotten. If I had 2 is less than 3, that's a true statement, right? But if I multiply both sides through by -1, I no longer would have a true statement if I opened this way because -3 is actually the smaller term. So it's going to have to switch. So remember, anytime I multiply or divide by a negative value, my x is going to switch back and forth. Okay? My inequality sign is going to do that. We're going to look at one here. Now this one is tricky because I've got 2 possibilities, right? This and this, and so my answer is going to lie between 2 numbers. I don't know what those numbers are, but it'll be between those 2. And then I also have some kind of rational expression here. So when we were doing equalities and rational expressions, I said we'll just multiply through by x plus 4 on both sides, because that would make our life way easier. But now here's the trick, or the problem with this. I made an assumption here when I put my arrow that way, because remember, if I multiply through by a negative number, I have to switch the inequality sign the other way. Do I know if the quantity x plus 4 is positive? I don't know that. So what I technically should do is I should write two equations, one where it's this way and one where it opens the other way. Now that sounds like a total nightmare, and then I would have to do it all over here again. So instead of making my life miserable, here's what I'm going to do. I'm going to go to Decimos, or whatever my graphing software would be. Yours would be a calculator to make that work for you. And I went ahead and I graphed the original equation. So I said, here's the left side of my equation, here's the right side of my equation. And I want to know when the output of this is less than, so the output, the y value is smaller than the output of 2. So I found my intersection. There's one at an x value of -2 2/3. Here's a y value. They intersect at x equals -8 and -2 2/3. And then to the left of that value, where x is less than -8, the output is less than 2. And when x is greater than, this way, -2 2/3, my output is less than 2. So this is what that would look like when I went to write it in my actual answer. So could have done a lot of hard, terrible, tedious stuff, or I could use that wonderful world of technology and then just use my brain to interpret what the answer should be. So you did see some equations like that on the last assessment. It was a question like this where it said, show me where f of x is greater than g of x. And you just plugged in one function and graphed it, and then graphed the other function. And then again, just looked at the graph. When is the output of one larger or smaller than the output of the other? So using our analysis to answer the question instead of just relying on the algorithm.